We're looking here at number 4 from the test. Number 4 says, use the definition of the derivative to show that the derivative of f of x equals 1 over x squared is negative 2 over x cubed. The key to understanding what it's asking us to do is to read it carefully enough to see that it's asking us to use the definition of the derivative. It's not asking us to use any rule or formula. It's certainly not asking us to use the quotient rule. No, it's asking us to use the definition of the derivative, which means you have to remember what is the definition of the derivative, and you need to carry out the algebra that uses it. So here is the definition of the derivative. If f is a function, then the derivative of f at x is equal to the limit as h goes to 0 of this quotient, of the quotient f of x plus h minus f of x over h. This is the definition of the derivative. Definition of the derivative function. Okay, let's use that in the case when f of x is 1 over x squared. So here we go. Alright, so let's see. I'm trying to find the limit as h goes to 0 of what? Of f of x plus h. Well, look at what f of x is. F of x is 1 over x squared. So I'm going to replace the x's. Replace. The keyword is to replace the x's with an x plus h. What does that look like? It looks like this. It's 1 over, that's going to be the quantity x plus h squared. See, that's what 1 over x squared becomes when you put in x plus h. And from that we will subtract f of x. F of x is 1 over x squared. So here it is. 1 over x squared. And all of this is over h. We need to do some algebra to clean up this numerator. So I'm focusing on the numerator now. I'm going to let's see. I'm going to go ahead and maybe this would not be a bad time to find a common denominator even now, right? So watch what I do here. To get a common denominator, I'm going to multiply the top and the bottom of the first term by x squared. So it's x squared over x squared times 1 over, here I have this x plus h squared, right? Minus, now over here, to get a common denominator, right, I need to multiply the top and the bottom by x, the quantity x plus h squared, right? So this is the quantity x plus h squared, top and bottom. The purpose of doing that was to get a common denominator. Of course, all of this is still over h, and we're still taking the limit, right? This is still a problem of finding the limit. So this is the limit as h goes to 0. All right, so we'll just keep on doing our algebra. You have to do it very carefully. This is the reason why we practiced algebra all those years before we got to calculus. All right, so let's see here. Now this is x squared times 1. So don't forget to bring my limit with me. This is the limit as h goes to 0, multiplying the x squared times the 1. So this is x squared over x squared times the quantity x plus h squared, right? And this is minus, this is 1 times that quantity x plus h squared. So this is x plus h squared over x squared times the quantity x plus h squared. So far so good. All of this is over h. That's right. Okay, now's the time to do some expanding, right? You know what. Should I do that on the side over here? Would you like me to do that on the side so you can see it? What is x plus h squared? Well, x plus h squared means x plus h times x plus h. So that's going to be x squared plus xh plus another xh plus h squared. So I'll get x squared plus 2xh plus h squared that is what x plus h squared is. We can actually write that out on the top now. Okay? Got to be careful about the signs though. So this is the limit as h goes to 0 of what? Of x squared over x squared times the quantity x plus h squared, right? Oh, these are the common denominators now, so it's okay to go ahead and do the subtraction, right? So this is going to be minus what? Well, minus this quantity x squared plus 2xh plus h squared, right? See how I had to put the whole thing in parentheses because I'm subtracting a quantity like this? And all of this is over h. Alright, this is now the limit as h goes to 0. Can we clean up that? I'm going to distribute that negative in the numerator. So this is now x squared, and then it's minus x squared, and it's minus 2xh, and it's minus h squared, right? And all of this is over x squared times the quantity x plus h squared, and all of this is over h. So far, so good. Now we can combine the like terms in the numerator. So this is the limit as h goes to 0. You see this x squared and that negative x squared? Yeah, I do. So that those actually these guys are going to cancel, and we're going to get negative 2xh minus h squared over x squared times the quantity x plus h squared, and all of this is over h. Well, at some point we're going to have to actually do the limit, but everything we've done so far is just algebra, like you would have seen in Algebra 2 or pre-calc. Haven't even actually done the limit yet. Maybe, I don't really like how I have it. This is a fraction, right? On the top is a fraction, then we're dividing by h. You can think of this h as being like h over 1, right? So now I have a fraction on top and a fraction on the bottom. What do you have to do when you're dividing two fractions? Did you hear that? What do I have to do when I'm dividing two fractions? Well, what you do is you multiply by the reciprocal. So this is the limit as h goes to 0 of the top fraction, right? This is negative 2xh minus h squared over x squared times the quantity x plus h squared times the reciprocal of h over 1. What is the reciprocal of h over 1? Well, that's 1 over h, right? Okay, very good. So let's bring this all together a little bit. This is the limit as h goes to 0 of negative 2xh minus h squared over, right, because that was just this times 1. But now I get to multiply all of this by h, so I'll just bring it all together. We have h x squared times the quantity x plus h squared. Well, so far so good. But I think you'll see if I were to just substitute, if I substitute a 0 into h now, the denominator would become 0, and that's not okay. There is a problem there, but look at the numerator. Look at what's in both terms in the numerator. There's an h in both terms, so let's factor that h out. So this becomes the limit as h goes to 0 of h times, when you pull that h out of there, you have negative 2x minus h. How about that? Over, what? Down here is h times x squared times the quantity x plus h squared. That's right. And now do you see what can be done? There's an h here on top. There's an h. Now it's okay to cancel out those h's. What do we have now? I guess now we have, this is the limit as h goes to 0 of negative 2x minus h over x squared times the quantity x plus h squared. And you see, now there is no there isn't going to be any problem substituting in the 0 for the h at this point. So now it's okay to do that substitution. Let's go ahead and do that. So this is equal to, this equals, doing the substitution, negative 2x minus 0 here, right? Because I'm just going to replace the h with 0. Down here we have x squared times the quantity x plus 0 for that h right there. Now let's simplify this. This becomes, so negative 2x minus 0 is just negative 2x. Down below, this is x squared times the quantity, well, x plus 0 is just x, and then it's squared, so this is x squared, right? Which is equal to negative 2x over x squared times x squared is x to the 4th. But you see how now there's an x to the 1 on top, there's an x to the 4 on the bottom. So you have 1x on top and 4x's on the bottom. Let's cancel an x from the top and an x from the bottom, and we'll end up with, this is equal to negative 2 over x cubed. But aha, look at this. This negative 2 over x cubed, that is exactly what we were hoping to show. Oh, gotta keep on going right on up there. We'll find it up there someplace. I'm confident that we will. Let's keep on going. Yep, keep on going all the way back to the very beginning. If you look all the way back, right here, the actual question was asking us to show that the derivative of this guy is equal to that. There's our negative 2 over x cubed, and that is exactly what we just did. Right? If you go all the way back, follow all of that work, negative 2 over x cubed, this is what it means to use the definition of a derivative to find the derivative.